Hello, my name is Eric and I'm working for Eco Instruments here at Intersolar in Germany. This year we're demonstrating a soiling system and we want to show you the impact of non-uniform soiling on a PV array. What we have over here, we have a module that is kept clean always. This is our reference module. And over here we have an array of 4 different modules, like a normal array you will see in the field outside. If we have both systems clean and we're trying to measure the performance, what I will do now, this is a live measurement, then we will see that we get normal curves, we get normal power output, and we can compare the values as they are. So over here we see the IV curve of our solar array. It's a nice curve, it's clean, and if we measure with our PV mon the real output of the array and our clean module, we will get the following data. What we see over here is the measured power output of our array, which is exactly in the power max point. This red dot is indicating the current generated by our clean module, which should always be the same because the module is kept actively clean. Now what happens if we make our soiling system, if we make our array dirty? So we are simulating some kind of soiling. We put a transparent paper over our array and we're doing a new measurement. It's now truly measuring the array, the output, and we expect it to go a little bit lower as there is soiling on top of the array. Over here we see a new graph, a green graph, and you see clearly that our power output is lower. Now let's measure this with our product, the PV mon. I press measure. As the reference module is still kept clean, it should have the same output. And we can clearly see that at this red dot that the output stays the same. However, the power output is now much lower, which we measure here. This is all clear and easy to understand. Now what happens if the soiling of our array is non-uniform, which means you don't have the same dust everywhere. Let's say you have a lot of dust on your modules and a rain is falling. Then the dust will go down and will accumulate down at the bottom of the solar modules. This sounds like no problem, but if you measure the output of your array at that moment, you will get the following. We are demonstrating non-uniform soiling by this little strip. I have my array here, everything is clean, and by covering the bottom part of the array, I'm simulating non-uniform soiling. Now let's do a measurement and see what comes out. We expect to have a much lower current because we're covering things, but as you will see, something else is happening. We are getting a step. This is caused by the bypass diodes in the array, and this will be everywhere. What you see here is that if we are only looking at the current output of the array, which many systems in the field are now doing, then you will see that there's only a little difference in output. But if you're measuring the true power output of a system that is non-uniformly soiled, which I will do now by measuring it, I will see that it's not this difference, but this difference. The difference is much higher. So you're getting much more accurate readings by measuring the true power output of a soiled system. This is the way we hope to contribute to soiling measurements in the field. Thank you.